Hello everyone. In this video, we will learn four important sorting algorithms like insertion sort, merge sort, quick sort, heap sort with a simple Python program. So let's start. So first we have to see what is sorting. Sorting is the process of arranging data in ascending or descending order. So what is the purpose of sorting? Like make a searching, analyzing, managing and a data faster and easier way. So these are the types of sorting. First one it is a insertion sort, second is a merge sort, third one is a quick sort, and fourth is a heap sort. So what is insertion sort? Build the sorted list in one element at a time, that is the insertion sort. And merge sort in that divide the list, sort each half and then merge. So this is the merge sort. And quick sort in that pick a pivot element, then partition element into the smaller or greater, then start recursively. Then what is the heap sort? So in that uses a heap data structure to repeatedly extract the largest or smallest element. So this is our four sort. So we have in demonstrate. So first we have to perform insertion sort. So first we have to perform insertion sort. First we have to define the function for insertion sort. Like A. Then taking a for loop for defining I in range. That start from the second element and pick each element as a key. So that's why we can take a for loop. So start index 1 and then length of the array. Then defining our array, j is equal to I minus 1. So what we say while we're taking while loop, in that a shift element in that shift element a bigger than key to the right. So that's why we're taking the while loop. So increment the counter. So we can take the j plus 1 and it's equal to key. So in that way, a is equal to a is a j plus 1 in that insert the key in the correct position. So that's why we're taking the that function. So again, we can perform merge sort. Taking a defining function, defining merge. In that first we split the array into two halves using mid is equal to length of a floor division by 2. So then we recursively sort both halves with merge sort like a left and merge sort with the right. So again, first we have to take left half and then I will take the right half. Same as defining a function. Then so just reverse the function. After that, this our both halves like a left and merge sort right. After that, we merge the two sorted halves using the loop. So taking the while loop, then I is less than or greater than, performing both operation like greater than or less than. Then taking the left half and we can increment the our counter I plus is equal to 1 I. In that we can take I plus plus is, so in that loop after if we can take else loop. So else loop in that we can append any remaining element or as a result the full array becomes completely sorted. So that's why we taking that function. So that's where we can defining the merge sort. Then we can perform quick sort. So quicksort basically work by selecting the pivot element and dividing the array into two parts. Like elements are smaller than or equal to the pivot to the left side, and elements are greater than the pivot, then go to the right side. So defining that way. So first defining the create the function of quicksort or a element like the parameter. It will then from loop if Same as recursive function perform on right side. Same function like x for x in, but it is a greater than or is equal to P After that, return So, in short, what we can perform, quick sort work by selecting the pivot element, right? And dividing the array into two parts, like elements smaller than or equal to the pivot, go to the left side. That way, go to the left side. And the element greater than the pivot, elements are greater than the pivot, then the pivot go to the right side. So we can recursively the sort the left and right part, and combining the sorted part with the pivot give the fully sorted array. So final, in that we can give the our final output. Same as performing our heap sort. So heap sort basically convert the array into the heap data structure, which allow us to efficiently access the smallest or largest element, like min, heap, or max heap. So how we first we have to define the heap sort function. Import heap queue method, then heap queue, and using heapify method for performing this to create the min heap and max heap. Then return our heap of a first I, and then I will explain what I did. So, so this is our heap sort. So what we can do, heap sort first convert the array into the heap data. Okay, heap data structure like mean heap or max heap, which allows to the efficiently access the smallest or largest element. So then we can repeatedly remove the root of the heap and rebuild the heap until all the elements are sorted in that way. In this, in this method. So we create an array and use copies of it into the sort with the insertion, merge, quick, and heap sort. So finally we print. So finally we print the original and sorted array for each algorithm to see the result. So let's see the output of our program. So let's output. Let's, so let's see the our output of our program. So this is the output of our program. So that's how we sort an array using insertion, merge, quick, and heap sort. All algorithms are the same sorted result, like ascending order. So in that, helping us organize data efficiently. So I hope this explanation was very easy. Thank you for watching.